Hello, this is Ho Jin-jang in Chemical Engineering at Sungkyunkwan University. In this time, we will talk about mimic-dosed dopant system using X-plexes in organic light-emitting diodes. Until now, in the direct intermolecular interaction reduction method, where inertosed co-doping was carried out for X-plex-based OLED improvement. In this time, we will deal with indirect intermolecular interaction reduction method by controlling mixing ratio. In this figure, the ratio of one X-plex component is reduced and dispersed in other components of material. By this ratio control, X-plex is also dispersed, then intermolecular interaction between components or X-plex would be reduced. Finally, X-plex concentration quenching and TT effects become suppressed. In this chapter study, the various p-type and n-type pairs are prepared, and the reducing component was p-type, so n-type material should be bipolar host. Selected p-types are TABC, PCZAC, and n-type bipolar was TPCZ and TSICZ. The pairs are 3 like this, and p-type ratio was 5, 10, 20, and 50%. As shown in pair spectra, X-plexes are generated and emission energy were typically increased. This can be assumed that stabilization energy loss is decreased by interaction reduction. In the analysis of transient pair curves, as ratio decreases, the delay emission component become increased due to reduction of interaction and external loss. However, in the pair QI shows a different tendency that second pair have a maximum value at 20%, others are maximum at 5%. The main reason was a homolumo energy offset between p-type and n-type material. In first and third pair, they have a large homolumo energy offset, so holes are mainly on p-type homo and X-plex is dominant even at low contents ratio. On the other hand, second pair has a relatively small energy offset, so holes can easily drift to n-type at low contents ratio. Then host extone can be generated and it makes PQI loss. With this data, device improvement test was carried out with different X-plex pairs and consent ratio. As shown in graph, maximum EQ was following PQI tendency that large offset X-plex has maximum and lowest ratio, and other small offset X-plex has maximum at specific ratio. Also, efficiency drop by triple loss was prevented effectively. In calculation with this EQ equation and assumed values, the difference between theoretical and experimental maximum value becomes smaller as consent ratio is decreased. In conclusion, X-plex device efficiency can be improved and external loss also suppressed with mimic-dosed dopant system. This is the end of this chapter. Thank you for listening.